Good morning, my students. Today, in this video, we are going to study how to write electron configuration of an element. In the last two classes, we explained section 2, electron arrangement in atoms. We watched some videos about these sections, and today I'm going to talk about this lesson in brief way so we can move to the other section, to section number 3 for chapter 5. As we studied in the last class session, there is 3 rules we have to follow for writing the electron configuration of elements of Pauli principle, Pauli exclusion principle, Pauli exclusion principle, Hunt's rule. And we mentioned that we have to memorize the Aufbau diagram so we can write the electron configuration of an element. And one of you mentioned an easy way to memorize the Aufbau diagram, and as I told you to write it in your notebook, it is like that. To write the electron configuration of any element, you have to memorize S, base, debes, F, debes, F, dep. Now we have to put numbers before each letter which refer to the main energy level of the sublevel here. The first S sublevel, we put here 1. The second, 2. The third is sublevel 3, 4, 5, 6, 7. And the B sublevel start from the second main level. So we start here from 2, 3, 4, 5, 6, 7. And D sublevel start from the third main energy level. So we start the first D, but number 3, 4, 5, 6. And F, we start number F, 4, 5. This number refer to the main energy level that each sublevel S, B, D, F exists in. Now we have to memorize, or we have to know also, that each S sublevel can at most describe 2 electrons, and that's because S sublevel contain only 1 orbit, and we can represent an orbit by drawing square or but dash. Each B sublevel contain 3 orbits, so we can draw 3 squares or put 3 dash, and I prefer to write dash because it is easier for you. And that's why B sublevel can at most holds 6 electrons. We can put 6 electrons in B sublevels, while D sublevel contain 5 orbitals, 4 with the same shape and the last one with different shape, and it can hold at most 10 electrons. F sublevel 7 orbitals in each F sublevel and can hold at most 14 electrons. Now, let's try. That's what we have studied in the last 2 sessions in our class. Now, I will try to answer question number 8 and question number 9, page 136. Page 136. Now, in this question, he asked us, write the electron configuration for each atom. We have to know that there is different types of electron configuration we can write. Here, in your book, he mean by writing electron configuration either of orbital diagram electron configuration or electron configuration notation. I will write this. I will try to answer A and C, and I will leave B as a homework for you, and I will try to solve B here and leave A and C for you to solve and as a homework on your notebook. Now, write the electron configuration for each atom. Carbon. A, carbon. He wants question number 8, page 136. A, the element carbon. He wants me to write the electron configuration. To write the electron configuration of carbon, you must know the atomic number of carbon. Now, carbon, C, the atomic number of carbon, you can refer to the periodic table. It is here, C, in group 4, period 2, the second horizontal law, period 2, group 14, carbon, atomic number 6. Now, 6. To write the electron configuration of carbon, it is start with S, and this can holds 2 electron and 2 electron. Because the atomic number of carbon is 6, the electron number of carbon, it is atom is 6 also, which is equal to the atomic number. So it is not enough to just contain S2S sublevels. So we'll try SS, PES, right, PES. B sublevel can hold 6 electrons, but we only have 2 electrons remain with us, because here 2 electron and 2 electron, it is 4. Now we only have 2 electrons. B can hold 6 electrons, so we can put 2 electrons. We didn't use this S sublevel. We remove it. Now, put the number of energy main level of each sublevel. 1s, 2s, the first B letter 2B. Start with B, we start with number 2. This is the electron configuration of carbon, For C, nickel, it is here, and nickel here with atomic number 28, Ni 28. F1, Ni 28 atomic number, SS 22, PES 6 2 6 2, here 10 electrons and here 10 electrons, we have 8. SS PES DBES, D can hold 10 electrons, but we only have 8 electrons. We put 8 here. We didn't need B and S. Start numbering 1s, 2s, 3s, 4s. The first B sublevel 2B, 3B. The first D sublevel 3D. This is the electron configuration for nickel. Now let's try. I will leave B as a homework for you. Now for question 9, 136, I will try to solve or answer B. Silicon. Silicon Si. The atomic number of silicon, as you see from the periodic table, 14. Now here he wants me write the electron configuration for each atom. How many unpaired electron does each atom have? To know how many unpaired electron in an atom, you have to write the orbital diagram electron configuration. What we mean by orbital diagram? It is here 14. S, base, here one orbit, 3 orbit, 1 orbit. Now here we can put 1 electron, 2, 1, 2. Here we can put 6, 1. Look, 2. How we fill? Look how we fill the orbitals of each sublevel. 4, 5, 6, 1, 2. Now we have here 12 electrons, which means there is 2 electron remains for silicon atom. SS, PES. For B, 3 orbitals. Now we only have 2 electron remains for silicon. We will not use this. How we can write the 2 electron? 1 in the first orbit, 2 in the second orbit, as Hund's rule say. Now this for the first main energy level, the second, the third. This for the second, and this for the third main energy level. Now as you see here, 2 unpaired electrons. 2 unpaired electrons. He asked here How many unpaired electrons? Two unpaired electrons in silicon atom. I will leave A and C for you as a homework. Thank you.